In this video, I would like to discuss factors. I will discuss what a factor is, go through detailed examples of how to calculate factors of a number, and show you a trick of how to work out factors of large numbers quickly. So, what is a factor? A factor is a number that divides exactly into another number without leaving a remainder. Another way to think of factors are all the numbers that can divide into it a whole number of times. A factor must contain whole numbers, for example 1, 5, 8, not fractions or decimals. Every whole number greater than 1 has 2 or more factors. When a number is divided by one factor, the answer is another factor. The two factors are called a factor pair. The product of each factor pair is equal to the number. So let's go through some examples so we can really understand this. Let's take a look at the number 24. Factors of 24 are all the numbers that divide into it a whole number of times. So for example, 6 is a factor of 24 because 24 divided by 6 is 4, which is a whole number. Whereas 5 is not a factor of 24 because 24 divided by 5 is 4.8. So 5 doesn't go into 24 a whole number of times. Let's go through some more examples. Let's look at factors and factor pairs of 18. As a tip, the first factor pair is always 1 and the number itself. So 18 divided by 1 gives an answer of 18. The division here gives no remainder, so the factor pair is 18 and 1. Now 18 divided by 2 gives an answer of 9. The division here gives no remainder, so another factor pair is 2 and 9. And finally we have 18 divided by 3, which gives us 6. The division here gives no remainder, so the factor pair is 3 and 6. So we can summarize the factor pairs of 18 as 18 and 1, 2 and 9, and 3 and 6. Giving us factors of 18 as 1, 2, 3, 6, 9, and 18. A quicker way to work out factors of a number are by writing all the factors starting with 1 times the number itself. So if we wanted to find out all the factors of 28, we would start with 1 times 28 and then 2 times a number that when multiplied would give 28, and in this case that would be 14. And then we'll move on to 3 times a number, but 3 is not a factor of 28. So let's move on to 4 times a number, and 4 times 7 gives 28. We'll move on to 5 times, but 5 is not a factor of 28, so we can cross that one out. Let's move on to 6 times, and again 6 is not a factor of 28, so we can cross that out. And then we move on to 7 times, but we have already covered 7 in 4 times 7, so we can stop at this point. So the factors of 28 in ascending order are 1, 2, 4, 7, 14, and 28. Let's try another example. Find all the factors of 35. We would start with 1 times 35, and then 2 times, but that is not a factor of 35, so we can cross that out. And then 3 times a number, but 3 is not a factor of 35, again we can cross that out. And we'll move to 4 times, which again is not a factor of 35, so we can cross that out. And then we move to 5 times a number, and the number multiplied with 7 would give us 35, so 5 is a factor of 35. Then we move to 6 times a number, but 6 is not a factor of 35, so we can cross that out. And then we move to 7 times, but we have already covered 7 times when we did 5 times 7, so we can stop at this point. So the factors of 35 in ascending order are 1, 5, 7, and 35. Now we can move on to a trick for large numbers. Previous methods for large numbers, there could be an element of guessing the factors as we list all the factor pairs. This method I'm about to show you removes all guesswork out of working out factors of any number. This trick involves prime factorization. If you do not know this method, I have tagged a video above for you to take a look at. With the previous method, you can miss some of the sneaky pairs of factors, but with this method, you can quickly figure out all the factors. So start with a question of find all the factor pairs of 90. So we start with 90 and we split this into 2 and 45, as 2 times 45 is 90. Since 2 is a prime number, we can circle this, and then we concentrate on the other branch, which is the 45. So how can we split 45? We can split 45 into 5 and 9, as 5 times 9 is 45. And since 5 is a prime number, we can circle it and concentrate on the 9. And 9 we can split into 3 and 3. And 3 is also a prime number, so we can circle these. So now we have 90 split into its prime factors of 2 times 3 times 3 times 5. We can use these numbers to figure out our list of factors that go into 90. So how can we use this? First, we know that 1 times 90 is 90. And we also know that 2 times 45 is 90. Then let's move on to 3 times. If we look at our prime factors, we can see 3 is there. So for now, let's circle it. And if we multiply 2 times 3 times 5, which are the remaining prime factors, this gives us 30. And 3 times 30 makes 90. So 3 is a factor of 90. Let's move on to 4. Since when looking at our prime factors, we can't make 4 by using any of the prime factors, we can say 4 does not go into 90 to give a whole answer. So 4 is not a factor. For 5, we have a 5 in the prime factors. So let's circle that. And if we multiply the remaining numbers, which are 2 times 3 times 3, which gives us 18. So 5 times 18 gives us 90. Again with 6, we can make 6 by multiplying 2 times 3 from the prime factors, and what is remaining is the 5 times 3, which gives us 15. And 6 times 15 gives us 90. 7 is not a prime factor in our lists, so it will not go into 90. And 8 cannot be made using any of the prime factors, so this does not go into 90. And we know that 9 times 10 makes 90. Now moving on to 11 to 14, we cannot make any number between 11 to 14 from our prime factors list, so we know that these do not go into 90. 15 we have already seen, so our list of factors for 90 are 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45 and 90. This trick is handy when the question asked has a large number that you need to factorize. Let's try another example. Find all the factors of 196. So let's start with 196, and we can split this into 2 and 98, since we know that 2 times 98 is 196. And 2 is a prime number, so let's circle this. And let's concentrate on the 98. Now, for 98, we can split this again into 2 and 49. And we know that 2 is a prime number, so we can circle that and concentrate on the 49. And 49 can be split into 7 and 7. And 7 is also a prime number, so we can circle both these prime numbers. So now we have 196 split into its prime factors of 2 times 2 times 7 times 7. We can use these to figure out our list of factors that go into 196. So how do we do this? First, we know that 1 times 196 is 196, and 2 times 98 is 196, and then we move on to 3. Since 3 is not in our list of prime factors, we can say that 3 does not go into 196 as a factor, so we can rule that out. And let's move on to 4. Now 4 we can make by using 2 times 2, and the remaining prime factors of 7 times 7 give 49. So we know that 4 times 49 is 196. So 4 is a factor of 196. For 5, we do not have a 5 in the list of prime factors, so 5 is not a factor of 196. Again with 6, we can't make 6 from the prime factors, so 6 is not a prime factor of 196. And 7 is in our list of prime factors, so let's circle that, and we multiply the remaining prime factors of 7 times 2 times 2, and that gives us 28, and 7 times 28 gives 196. So 7 is a factor of 196. Numbers 8 to 13 cannot be made using our prime factors, so none of these numbers are factors of 196, but 14 can be made using our prime factors of 7 times 2, and multiplying the remaining prime factors of 7 and 2 gives 14, and we know that 14 times 14 is 196. Numbers 15 to 27 cannot be made using our prime factors, so these numbers are not factors of 196. And then we move on to 28, but we have already used 28, so we can stop here. So the factors of 196 are 1, 2, 4, 7, 14, 28, 49, 98, and 196. So in summary, in this lesson we have learnt that a factor is one or more numbers that divides into a number without a remainder, making it a whole number. In other words, a factor is a number that divides another number evenly. There are no numbers left over after the division process. I have also shown you a trick to work out factors of any number without guessing by using prime factorization process. So the final example is find all the factors of 15. Again, numbers it can be divided into to give a whole number are 1, 3, 5, and 15. That's all for this video. Hope you found it useful. If you did, please give a like and subscribe, and I will see you in the next video.